I am going to talk about some ideas and introduce two theorems that we're going to see in our next notes. If you would like to follow along, this will match with our 2.5 notes. I am going to show you some things outside of this. And so some of this might be for you to follow along, or if you want, you can make a blank page and take some notes if you want to remember this for later. So before we get into addition and properties or addition and subtraction properties in angles and segments in our geometric concepts, let's go back and do a quick review of addition properties and subtraction properties in normal algebraic settings. These are things you've used for years and maybe haven't realized it. So the addition property of equality says this: if I have a quantity, so if A is equal to B, then that means that I can add a value onto one side of the equation, and to balance it, I have to add the same thing on the other, and that equation will still be equal. It will still be equivalent. So if A is equal to B, then A plus C is equal to B plus C. I can add the same quantity in on both sides of the equation into the equation, and it will stay equal. So you've seen this before, and that means that these two sides are still equal to each other. That is super important. Same with subtraction. If A is equal to B, then that means that I could subtract the same quantity and the two sides would still stay equal. So that would mean A, rewrite that here, then that means A minus C would be equal to B minus C. I can subtract the same quantity from both sides and it would stay equal. So then that's going to move us into this next diagram. In this diagram below, segment AB is equal to CD. Those measures are the same. So AB is equal to CD. Those are congruent. We can mark them with one tick mark. I want you to think for a second. Do you think that AC is equal to BD? So we're saying AC, is it equal, its length, is it equal to BD? Well, maybe the answer is clear to you. Maybe it's not so clear. Let's add something into this. What if we put some numbers on this? So AB is still congruent to CD. Let's say that BC was 3. And let's maybe say that AB and CD were 7. Let's think about this with some numbers. Okay, so we're seeing if AC would be equal to BD. Are their measures the same? Well, AC is simply the addition of AB and BC. So that means that AC is 7 plus 3, so AC is 10. Similarly, BD is also 7 plus 3, so we left off the D here. So BD is also going to be 10. So this looks like if BC is 3 and the other two sides are 7, then awesome. That means those segments are congruent. Well, moving forward, we want to think, does it matter? Do I specifically have to be told the numbers in order for those to be congruent? So it works in this problem because I have numbers. I can put values on this and figure it out. Or does this work for a diagram like this of any size? So I want you to think, does it matter what size the segments are? And the answer to this is going to be no. What we did is I took two congruent segments, AB and CD, and I added in the length of BC. I added segment BC onto each of those two segments. I extended them out by the length BC, and those are going, because I'm adding the same amount, the same object onto both sides, it's going to keep them congruent. So what that means for us here, if we're going to prove this real quick, so we're going to start with our given. So we are going to start with AB. Oh, this white is kind of nice. AB is equal to CD. So then what we also know is that AC is going to be equal to AB plus, actually, let me go back here. We're going to go back. So there's two ways we can figure this out. We can figure out that they are going to be equal to the same thing. Remember that we learned our substitution property. So that's going to come into play here in just a second. So let's investigate segment AD. So that means for us here that, or sorry, AC. The AC is going to end up being equal to the length of AB plus BC. And this is called a segment addition postulate. A longer segment is also equal to the length of its two subparts or however many subparts it has. And that also means that BD, similarly, is equal to BC plus CD. Awesome. Okay, so these are just looking at the subparts for the two larger segments that I am trying to prove congruent. All right, well, I will remind you that AB and CD are congruent to each other, or they're equal to each other. So that means I can replace their measurements. So next up in our, this is a paragraph proof. So by substitution, I'm going to take BD, the segment BD. So that means BD would be equal to, remember that if things are equal, I can substitute them in their place. So that means it would be equal to BC plus AB. Well, won't you look at that? Now I have proved that AC and BD are equal to the exact same thing, and the order doesn't matter in terms of how we had chosen to substitute it, but that means that we're going to use the word thus. Thus, AC is equal to BD by, AC is equal to BD by substitution as well. All right, so now I have proved it didn't matter what the numbers were. I don't know what the lengths are, but I have these segments. And in this specific diagram, what we are doing is I'm taking two congruent segments and I am adding the same other segment onto both pieces. I took AB and CD, I added BC onto each of them, and by this idea of our addition property, the result stayed equal. All right, so moving forward, I want you to think here for a second, does this similar relationship work for angles? Well, let's think about it. If I know that AEB, and DBC, sorry, ABE and DBC are congruent because it says they have the arcs on them, they're both 50 degrees. So the diagram shows me here these are congruent by the markings. So if I were to ask, is angle ABD congruent to angle EBC? The answer is going to end up being yes, because I am taking the angle in the middle and to form, and I realize I just wrote the wrong thing here. This should be ABD. Should ABD be congruent to EBC? And so for that, we're taking this angle in the middle. I'm adding it on to each of these. Let's say it was 20 degrees. That would make ABD 70 degrees and EBC 70 degrees. If I add the same angle onto two congruent angles, the larger sums, those resulting angles, will be congruent. That's going to be our very first theorem that we're going to summarize here at the end. All right, so this next one, I'm going to plant the seed for us here. We're going to spend a little less time here. First thing that we know is if we look at this diagram, there's a bunch of arcs, and these arcs are going to be really important for us. So let's first summarize what this diagram gives us. This diagram gives us that, oops, hold on. Okay. All right, this diagram gives us that angle 1 is congruent to angle 2 by the fact that it has the arc with the tick mark on it. That means those two angles are congruent. It also gives us, with the double arcs, that angle 3 is congruent to angle 4. Now, because they're different, it means 3 and 4 are congruent, but they're different from 1 and 2, different measurements. So looking at this, do you think that we could logically conclude any other angles are going to be congruent to each other? I'll give you a second to think about it. And hopefully what you might start to see here is that on the sides at B and at C, there is a connection where angle ABC is equal to angle 1 plus angle 3. Also, on the other side, angle ACB is equal, let me just rewrite ACB real quick, that looks kind of sloppy. ACB B is equal to angle 2 plus angle 4. Well, interestingly enough, if I look at both of those parts, 1 and 2 are congruent, and 3 and 4 are congruent to each other. That's going to end up meaning that I am taking the same values, the same numbers, and setting them up and adding them equal here. This is going to allow us to add them together in each side and conclude that those larger angles are congruent. Angle ABC would have to be congruent to angle ACB. Things that are abstract always get a little bit better with numbers. Let's say that those congruent 1 and 2 were both 15 degrees, and 3 and 4 were 45 degrees. Well, hopefully with these numbers, it should be clear for you to see those larger angles would add up to both the same numbers on either side, so they would have to be congruent. So we're not going to prove this one fully right now, but I wanted to plant this seed in your mind. So we are going to have two, and I switch these up here, we are going to have two theorems that deal with addition. And I'm going to introduce them here, and then we're going to pick our notes back up. Also add these, you can add them now or you can add them when we get back into your notes. And we're going to start back with this in class this next week. So the first theorem working with this postulate says this. If an angle is added to two congruent angles, then the resulting angles are congruent. That's what we did in our first example. And this also works, I realized, let me switch this out. This also works for segments, which is what we saw. So if an angle or a segment is added to two congruent angles or segments, we can interchange this here, then the resulting angles or segments are congruent. And this works in the same world. So an angle added onto congruent angles or a segment added onto congruent segments. Okay, so that was our first example where I had the segment with BC in the middle. I added BC onto the two and I resulted with longer segments, and those longer segments were both congruent. So that's our first addition postulate, our first addition properties. And then for our second theorem of our addition property is if two congruent angles or segments are added to two other congruent angles or segments, then the resulting sums, so a sum is what we get when we add two things together, the resulting sums, which would be angles or segments, are congruent. If two congruent angles are added with two other congruent angles, then when we put them together, the larger sums are going to be congruent to each other. And these are the addition postulates. So the idea of this, the whole point that I wanted you to watch this, is to put some visuals to it, to keep in mind, to look at these relationships, to look at our segments as we work through and as we try to put some meaning behind the theorems that we're having. So now when we start class next week, hopefully you have a better idea of these theorems so that we can learn the subtraction side of it, and then we can also start using them. That is it. Now that you've watched this video, you are done with the geometry extra assignments besides your homework from the week.